Hello all, my name is Girisha. I am currently pursuing my first year MTech in Computer Science and Engineering at Vignan University. My registration number is 241FB04201. Today I am going to explain about NQueen problem in design and analysis of algorithms. Before going to the NQueen problem, let's see what actually the backtracking is. Backtracking is a problem solving method where we try to build a solution step by step. If you realize that current choice can't lead to a correct answer, if you undo the choice, go back one step and try the different option. So now we will know about the NQueen problem. What is an NQueen problem? The NQueen problem is a classic backtracking problem where we must place NQueens on an n by n chessboard in such a way that no two queens should attack each other, meaning no two queens can be in the same row, same column or same diagonal. In an NQueen problem, we have two popular categories. First one is 4-queen problem, consists of 16 cells on a 4 by 4 chessboard. Next one is a 8-queen problem, 8 by 8 chessboard, consists of 64 cells. Now we will talk about the constraints of an NQueen problem. Here we have 4 constraints to solve an NQueen problem. First one is no two queens should not be in the same row. No two queens should not be in the same column. If we place a queen on a 4 by 4 chessboard, we cannot place another queen on in the same row or on the same column. And same major diagonal, no two queens should not be on the same minor diagonal. We could not place even though on the same major diagonal or on the same minor diagonal. This image shows how we place safely 4 queens on a 4 by 4 chessboard. Here we will try to solve the 4 queen problem. The 4 queen problem requires placing 4 queens on a 4 by 4 chessboard in such a way that each row and each column contains exactly one queen. In this, no two queens should attack each other. Means no two queens can be placed in the same row, same column or on the same diagonal. We will look about the algorithm of a 4 queen problem. First one, place a queen on a row by row. First we try to place the first queen and next we will check if the placement is safe. If safe, we move to the next row. If the position is not safe, try the next column. If no column works, we need to backtrack and replace the previous queen to check the next possible solution until all 4 queens are placed safely. The total time complexity of a 4 queen problem is big O of n into n factorial, and the total space complexity is big O of n square plus big O of n for recursion stack. Now look at the general method. In general method, we try to place a 4 queen in every possible position on the 4 by 4 chessboard. So this image shows the 4 by 4 chessboard consists of the row numbers from 0 to 3. To start placing a 4 queens, we try to place queen 1 on the chessboard. Since the board is empty, queen 1 can be placed anywhere without any restriction. Let us place q1 at first position. Now our current path becomes 0, 0. Next, we try to block all the unsafe position for placing the further queens. So we are trying to blocking the row, column and the diagonal. Now we try to place the another queen. So after placing queen 1, some position became the unsafe now. So we could not place the queen 2 in those positions. Now we try to place the queen 2. We have two possible positions, 1 comma 2 and 1 comma 3. Let us try to place the queen 2 at 1, 2 and block the unsafe positions. We have a same row and the major diagonal and the minor diagonal. The current path becomes 0, 0 and 1, 2. So we placed two queens safely. Now we try to place the queen 3 at row 2. So here we have a no safe position to place queen 3 at row 2. Now we try to backtrack and change the position of the q2. Here we have a only possible position is the 1, 3. Now try to place the queen 2 at 1, 3 and block all the unsafe position to place the further queens. And now we try to place queen 3. We have only one position to place queen 3. So let's place queen 3 at the only position is 2, 1 and block the unsafe position. Now we try to place queen 4. So here we don't have a safe position to place queen 4 at row 3. Now we need to backtrack again and check for the safe position. So we need to change queen 1 at 0, 02, 0, 1 and block the unsafe positions. Now try to place again queen 2. So after blocking all the unsafe positions, we have only the safe position is 1, 3. Let's try to place the queen 2 at 1, 3 and block the unsafe positions. After placing q2, now we try to place queen 3 and we have only the position available for queen 3 is 2, 0. Let's try to place queen 3 at 2, 0 and block all the unsafe positions. So we placed queen 3 at 2, 0 and block the row, column and diagonal. Now we try to place queen 4. We have the only safe position is 3, 2. Let's try to place queen 4 at 3, 2. Now here we placed 4 queens without attacking each other. And we have the another solution also, that is the mirror image of this solution. Q1 is placed at 0, 2 and Q2 is placed at 1, 0. Q3 is placed at 2, 3 and Q4 is placed at 3, 1. These are the two solutions. After placing queen 2, we have the only position to place queen 3 is 2, 0. Let's try to place queen 3 at 2, 0 and try to block all the unsafe positions. Now we place queen 3 at 2, 0 and block the column, row and diagonal. And next try to place queen 4 at column 3. We have the only safe position is 3, 2. Let's try to place queen 3 at 3, 2. We successfully placed 4 queens without attacking each other. And we have the another solution also, that is the mirror image of this solution. So queen 1 is at 0, 2, queen 2 is at 1, 0, queen 3 is at 2, 3 and queen 4 is at 3, 1. This is the another possible solution four queens problem. Let's try to implement this solution in a state space tree. In state space tree, in backtracking, we use depth first search to implement all the solutions. Here, each level of the tree represents placing a queen in a specific row. The numbers at each node indicates that column where the queen is placed in that row. That path from the top to any bottom node represents a complete arrangement of four queens. Here we have two possible solutions, first one and the second one. These are the only two possible solutions in the entire state space tree.